Hello, everyone. Welcome to our panel on trends, challenges, and best practices for embedded vision. Thank you all for coming, and we hope we'll have an interesting discussion here today. When talking about edge AI or embedded AI, we understand deployment of AI applications at the edge of the network, close to the user, throughout the physical environment, somewhere closer to the data, unlike, for example, when we talk about data center deployment or deployment in the cloud. And today we have invited these four gentlemen, and I'll briefly read their names, and I'll ask also each of you to introduce yourself. So we have here John from Light Vision. We have here Or from Hilo. We have here Oliver from HEMA. And finally, Olaf from NVTech. Please introduce yourselves.
Okay, so thank you. Welcome to the discussion. My name is Oliver Helsner. I'm the CEO and Chief Visioneer of HEMA Electronics. We are into hardware, software development of embedded vision systems. We're a company based in South Germany, and we focus on FPGA-based systems for our customers.
Hi, pleasure to be here. Okay. Okay, pleasure to be here. I am Or Denon. I'm the CEO of Halo. We are an AI chip provider focusing on high-performance, low-power AI processing, mostly around vision applications.
Hello, I'm John Gross. I'm leading the product management and marketing at Allied Vision. Allied Vision is an industrial camera manufacturer, and we've done so for 30 years. And we have a wide range of industrial cameras, but also embedded cameras. And yeah, I'm happy to be here today and to discuss with the colleagues.
Also, a warm welcome from my side. My name is Olaf Munkelt. I'm Managing Director of NVTech. We do software for machine vision since 25 years. I think your company is even older, if I remember that correctly.
45, yeah.
But you are much younger than me, so that's the point. So we do embedded vision for many, many years, for probably like 15, 18 years. We started with the Hitachi SH4, a platform which probably some of you remember. Today, the landscape is completely different, and I'm really looking forward to this discussion. Thank you for inviting me.
Thank you, everyone. And my name is Ekaterina Serezidinova. I am a senior data scientist at NVIDIA, and I will be the moderator of this discussion. So without further ado, let's start with the first question. And the first question is, what are the most promising use cases for embedded vision? And what role does AI at the edge play? Let's start with you, Oliver.
Thank you. The applications that we see in AI, there is a ever-growing market in embedded vision applications. Might it be industrial, medical, security applications. And we want to see a lot of more stuff. If we want to do security applications, we want to see people, things. We do automation. We want to see products and quality. So there is a lot going on with the video. So we want to see images depending on different kind of technologies. And I think the AI applications will be identifying, I call it stuff, because it's so a wide variety from persons to objects to quality features of products, from food to technology. So I think the identifying stuff and maybe identifying and recognizing stuff. So if I see this, I have a kind of software that relates to what is this, and to support the people working on these systems to help them identify what's going on there. So I think that's the most important point.
From my perspective, I think the interesting parts where you asked about edge AI. So why do AI at the edge at all? I think there are two main reasons people are going in this direction. First, there are applications which are bandwidth constrained, where you have lots of information at the sensor side, but you don't really need much of it at the back end. And as you mentioned, security is a classical example. Retail is something that is starting to emerge. The other side of things that you want to do at the edge is things that you want to respond quickly to what you're seeing. And there where we see applications that are emerging in quality inspection, robotic control, driving stuff. It doesn't have to be a car. Anything that moves and needs to make quick decisions. All of these are definitely going very fast to the edge.
Yeah, so for me, I think we really have to distinguish. I think when we look at the factory floor, Edge AI can definitely improve existing applications mostly. But I think it's really something different if we look beyond the factory floor. I think that's where new use cases are created daily, and I think that's really where Edge AI excels the most, because in AI it can handle fuzzy environments. So it can be trained to a lot of things. In factories, it can improve what's there, but also rule-based algorithms are quite good in factory floor. But as soon as you go outdoors, for example, where you have different lighting conditions, different weather conditions, you have so many different parameters that I think that's really where Edge AI can excel. And I have an example, if I may, briefly. I flew in from Hamburg Airport this morning, and they have this new access control system when you enter with the car, where they have a gate. And today it was actually snowing. And I was in a taxi, and we were standing there at the gate, and it just didn't open. So you're not supposed to take a card anymore, but it's supposed to read your license plate. But well, it doesn't work so well yet in challenging outdoor conditions. But I think this will improve very quickly now in the coming time. And that's a use case, so that it really adds perception to machines and devices. And it also makes our life easier, because in an access control system like this, you don't have to push a button anymore and get a card out, but it just recognizes the license plate, it registers you, and when you exit, it knows who you are and builds you accordingly. So it makes life easier. So yeah, that's my take on it.
Last but not
Yeah, a
least,
few more comments maybe. Yeah, there is a separation, I think, between what's happening on the factory floor and what's happening in the non-manufacturing industry, as we say. So, and these applications, they differ in many, many aspects. If we look at this number plate recognition, it's probably not so much a question of the camera, not so much a question of the software, whether it's a rule-based algorithm or whether it's an AI-based algorithm. You probably need a better lightning or so. So the system approach, the system thinking is also very important. Every component can deliver a little plus, a little add-on, but you have to look at an application like as a system, whether it works as a whole and supplies an added value to the customer.
I really like the example of the license plate challenge, and let's talk a little bit more about challenges. And my next question would be, what are the biggest challenges of deploying AI at the edge compared to data center or cloud deployment? And let's start with Olaf this time.
I think there's usually this differentiation. You have edge-based system and cloud-based system. And the cloud-based system is used for all this heavy stuff. So training data and improving and continuous learning and whatsoever. And on the edge side, you have only this la 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 la, which really makes the application then happen. And I think this is, from an architectural point of view, this is basically correct. But many applications, they run as they are. So they don't want to have a connection to the internet. They don't want to have a connection to one of the famous cloud providers. For many, many reasons, privacy, security, also technical reasons. There's a latency time involved in here. So what we see, if we look at our customers, they are very careful in selecting whether they have an edge cloud and interacting approach, or whether they have a clear separation and a clear description of when they use the cloud and when they use the edge.
I think it's also about reaction time often. So if you need a very fast response, it's usually an edge thing, because there you can get a fast response. And if you go to the cloud, you always have to go there and come back and fetch a certain answer. So, and that's of course critical in, for example, on the factory floor, where you want to be as efficient as possible, usually also as fast as possible. So there, and then of course what Olaf mentioned, all the aspects of security and robustness, decentralized system, not rely on a connection. Those are also important topics. Yeah.
From our experience, one of the key challenges when you talk about moving from cloud to edge, for all of the reasons that Olaf mentioned, is the fact that initially systems that are designed for a very high performance environment, it's not trivial to port them to something which is resource constrained. And you're always resource constrained. If you're not resource constrained, you haven't done a good job in optimizing your embedded system. And it's not always the AI itself. It could be related to many other system aspects which you don't take into account when you do a very large-scale deployment, like how the pre-processing looks like, how the post-processing, how are you going to handle multiple streams, how are you going to manage latency in something that is very constrained. So I think the system aspect of things is one of the biggest challenges that we see for customers moving from cloud to the edge.
I think we mentioned most of the existing challenges, like the networking, not the latencies, bandwidth. Another topic might be when we talk about outside of production and factory, we have mobile applications. Yeah, is it precision farming where we have rough terrain or security or other things that we look for the power management. Yeah. So power is another topic that we should look like on, and then we have to differentiate on what kind of technology we base our system. Is it an FPGA-based, a GPU, CPU-based system? And then we have other alternatives that we have to react to. Yeah. Where is the AI software based on what kind of platform? So power, the connection, bandwidth, wireless, wired, these are, I think, one of the main topics that we have to look at when we decide about how to build the architecture. And then, of course, like you said, the security issue, if we have a remote working vehicle and there is someone stepping inside of the working range, we have to stop instantly. We can ask some Watson in Munich, hey, what do you think about the situation? So we have to be very precise and on point. So that thing will be for the security, safety issues, the main point. Yep.
I can very much relate to everything you said, because in my role as a data scientist, I focus on embedded devices like Jetson, and we're also trying to solve all these challenges. I'm very curious to learn, how do you cope with the trade-offs between performance, power consumption, and cost in embedded devices? Let's start with you, Oliver.
Okay, thank you. After we have named all these complications, power and so on, that's the task of HEMA. So we do customer-specific design. So that is the first part of the workshop that we do with all our customers. So we talk about the architecture. Where is the data? What kind of sensors do you have? How do you want to set up your system? What kind of processing unit do you have? What kind of software do you use? Is there maybe an AI accelerator chip necessary? What kind of cameras do we use? So then we look at the video data. It's mostly video. So what kind of bandwidth, video resolution we have? How many data has to be shoveled from one side to the other? Or do we build a decentralized smart component architecture and put an FPGA in the camera? Then we can handle all the fancy fizzy stuff in the camera, and we have a smart device that only reacts on a real necessary occasion. And that's how we go into projects with our customers to build this setup, and then we have to decide how we make a more centralized or decentralized architecture using, as I said before, mainly FPGA technology. Or maybe we have an application with 20 cameras, we need 2 FPGAs and a GPU because we have to do some graphics overlay or image fusion stuff. So the typical step is go into discussion, ask many questions about the application, and the architecture that should be in a mid or long-term range. How should it look like? What about modularity, scalability? And then we talk to all the people that are necessary for the project, like the sensor people or the software people. And of course, it's a hard work at the beginning, but I think that's how we should start these projects, to go through all these questions with the people necessary from all the different components that we deliver in this kind of system. Yeah.
So it's like solving it case by case.
It's case by case, and of course, when you look at the many projects, yeah, HEMA is 45 years in the business right now. Of course, there are basic structures. Of course, there's kind of models or kind of variants where you said, okay, there are 3 to 5 main architecture types that make the more sense. Yeah. But as I learned, yeah, for example, what is in AI and accelerator chips, I think we have some more discussions about how to build next possible applications. How could that look like? Yeah.
If I may, from another perspective, is you asked about optimizing performance, power, cost, thermal, of course, which is a huge issue. Another aspect which I think you hinted to it, but the importance of software cannot be underestimated, because a lot of your investment throughout both development and the life cycle is going to be on the software. You mentioned data. Data is not software. Data is a different dimension, and together all these needs to be taken in account together. How much do you want to optimize the deployment for, let's say, power consumption versus how much you want to make it easy to maintain? It really depends on what is your use case. So this is another aspect which many overcome at the first step. They always encounter it when they try to go to production, but something that you should be considering very early on in the process, and build the right capabilities internally or partner with the right partners to also take care of the software aspects, not only the hardware aspects.
Curious to learn, does your company have more software engineers or hardware engineers?
As a chip company, of course we have much more software engineers. It's about 3 to 1. And I think that's typical. Also, for our customers, it might not be the right proportion, but they realize that the initial proportion they assumed is not the right one, and they need to add data engineers, they need to add software engineers, embedded vision engineers, to make the solution good, or to partner with the companies who can do it.
Makes sense.
So my comment would be that luckily we don't have all those challenges usually at the same time, or only very few times we have them all at the same time. So for example, if I have a forklift in a company and I have an embedded vision system in there, they don't care whether it's 1 or 5 or 20 watts more for the embedded vision system, because they have all those 1,000 watts anyway to lift the loads. They don't care about a few watts. So it really depends on applications and what is more important. So and then of course, I mean, we are a camera manufacturer, so it's really important to look at the whole system. So of course the camera is only one component, but it really all the parts need to be looked at. Also lighting sometimes, and of course the whole system.
Lighting is so often overlooked. The importance of lighting
True.
to the
So what is important? I would say most important from my point of view is, what is your budget? So what is your budget for this application? Very often people have a very good idea about what they want to solve, what the problem is, what they want to overcome, what they want to make better. But then we also have to be fair and have to say, okay, what are you willing to pay for it per system? And then, you know, the educational phase starts. So if I would balance all these points, I would say, let's start after the technical description. What is your budget? Then we can see what kind of components, what kind of system may fit inside this budget.
I think the budget, but also the timeline.
And the timeline, yes, thank you. Yeah, sure.
You wanted to add something?
And maybe to give an answer, yes, if you have all the wish list, and then there comes the guy with the money and said no. And I think what is a good idea, when we see this approach of all these system on modules. Yeah, I can take a Jetson module, I can FPGA module or others. When we see a separate engineering phase in the project and going to product serial production phase, it is really easy to ramp up and down with your modules. So give the engineers the processing power that they need to sort out all these answers. And then, of course, you have to go in many directions. If you need more software, you can ramp up, you can switch your processing unit, or you can ramp down and say, okay, now comes the serial production, and we have to shrink down. And of course, we have to halve the software amount, and then we can scale the hardware too. So it's not only scalable software anymore, but with all these modules, you can scale and be modular in hardware too. So even after 2 years, when we say, okay, but we need 10 more features, yeah, and we have some more clever algorithms, we can upgrade the hardware again. So it's more growing and scaling possibilities nowadays to adapt to the situation, up and down.
Olaf, I'm curious, you said optimizing for budget. So imagine we have the tightest budget ever and the biggest network to deploy. Do you have any tips and tricks to share how to do that?
Ask the experts. So I think if there is a basic solution for whatever problem, and this involves an AI setup or say an inference machine or whatsoever, then in recent years what I saw from say a user of these kinds of technologies, there has been a lot of improvements. So there are many ways to strip down networks and still keep a decent level of accuracy which is needed for the actual application. So I think this is really going in the very right direction. And what I see is that there's still a lot of work which is done around this tiny ML framework, so to speak. So I'm looking forward to get more tiny stuff with still high accuracy.
Thank you. Let's move to the next question. And yeah, it's actually a continuation of the question I asked Olaf. What are the most promising approaches for optimizing AI algorithms for edge devices with limited resources? And let's reshuffle a little bit. Let's continue with John.
Well, I might not be the right one to answer this. We are focusing on the camera. Maybe it's more one for you.
Yeah, I think the surprising truth is that things are not improving that much over the years. If you look year over year, for instance, ImageNet, which is a classical benchmark, not useful to any practical sense, but it's good as a benchmark. We are gradually improving. We are reaching some limit, and of course, the more TOPS you invest in the problem, the more memory, the more buy a better processor. I'd be happy to sell you one. But eventually, it can only get you so far. And then it goes down to narrowing the problem space and defining better what you want to achieve. And that's, of course, much related to the data, or before that, the product definition. So I think that refining your product specification is probably the best way to start this optimization problem. Of course, having better tools is always helpful and lift some of the burden from these problems, which can be hard to specify exactly what you want to achieve under which weather conditions, from which lighting angle, etc. And you want to what is working in the field without any bad feedback, etc., or needing to fix it. But that's the way to go, I think.
Do you have any tips and tricks?
Just some basic knowledge and experience of projects, because as you said, there is no system that can solve all tasks at the same time. It will never be available, and it's not able to produce this system even with the cloud, and the cloud is not big enough to solve. So look at what you really want to, and And often when you look at the details that you are looking for, there is a lot to optimize. And I want to remember that when my parents founded a company 45 years ago, and I remember that there was neural networks some 20 years ago, and there are people that wrote their doctor's thesis about 30 years ago about neural networks. Of course, we had a hardware to evaluate 5 images. Nowadays, we can evaluate 5 million or something like that. But the basic question will still be define the tasks, look at how it happens, how it behaves, look at the system, maybe shrink down the really necessary applications, because it will not get better the more hardware you throw into it. Yeah? Even if we take 10 Jetson modules, if it doesn't make sense at the beginning, it will not go better with the best hardware ever. So go into the design phase and ask the right questions. I think that's the most important point to look at. Yeah. And then maybe even some things can't be solved today. Yeah? If you have to wait for the hardware to sort 5 million pictures, maybe it takes some time. Yeah? But there were really clever solutions in the midterm. Yeah? Your software, the Halcon software, is based on a lot of this stuff. When you look at the first version and the nowadays version, there's a lot of development in between. It was famous 20 years ago and it's now famous, but it's a huge difference how that grew and how it was available. So maybe some things can't be solved the way we like to today. Yeah? Look at a problem and see how it evolves. And we talk with a medical engineering company, and they have a product design phase of 5 to 6 years. Yeah, we have to start today. We don't know what's happening in 5 to 6 years. Maybe your next product will solve the issue. Yeah, but so look at what's possible now, and there is a timeline that you can scale and adopt to.
Thank you. Let's touch upon a very important topic, and you've all also mentioned it as one of the challenges, security and privacy in embedded devices. So how do you ensure the security and privacy of data on embedded edge devices? Let's start with Or now.
Okay. Actually, I think it's, you have the answer in the question. The ability to do processing on the edge is a secure architecture, especially when we talk about privacy. I mentioned in one of the previous questions that in many cases, video processing, you don't really want to know everything in the picture. You just want to get some insights out of it. And that's exactly what you want to do in terms of privacy. And in that sense, having things pre-processed, whether at the camera, at the video aggregator, but at the beginning of the pipeline, and not aggregating everything to a huge security risk at some central location, is, I think, the way to go. And this is the solution for this ongoing problem, because we see cameras being deployed everywhere, and it's not going to go away. It's not smart. They will go away, but we need to make sure that the data that they are collecting is only the data that we want the cameras to collect, and pre-process everything as soon as possible on the pipeline.
Makes sense.
I think it's a very hard question. I mean, generally in edge devices, you have an enclosed system, so you shouldn't be able to really get meaningful data away from it. But as you said, it starts really in the design phase of when you gather the data, and then that you really check that you have really tested all possible edge corner cases that you can get out. But it's tricky, I think, in AI too, because it's not like rule-based. You have a way to understand it. You can only try from the outside to understand the model, but it's not formulas in the end. Right?
Also, formulas were hard to protect.
Yeah, okay, yeah.
I think from the protection side, we provide encryption technology, so customers can protect using this encryption technology their data. But there's another point which is probably not technical. There are technical solutions for it to encrypt data. The real issue is who owns the data. and who feels he is the owner of the data, and what does that actually mean? So from our point of view, from MVTech points of view, we think our customers own their data, so we don't own this. We have also no right to use it, so to speak. And this is, say, a statement where many companies are also working along this level. But this contradicts if you want to train your data somewhere in the cloud. And you probably know we have this Datenschutzgrundverordnung. So, German Privacy Data Protection Act. I see a lot of smiles in the audience. I think you guys know what I'm talking about. So, the EU thing. So, that makes it already pretty hard to train your data somewhere at Microsoft Azure Cloud, because in theory, the US government would have access to it. This is a pretty hot topic on various levels. But if it trickles down to us in this industry, we simply see a lot of hesitation of our customers that they really want to use this kind of technology in, say, an international framework. They want to adopt this technology for themselves in terms of they have internal clouds or company-based cloud inside their company. And then everything is okay. Then they control this. But there's big hesitation really providing that data up to the cloud. Encryption back and forth, this is the basic point, and there's still no solution for it.
Question to you?
Yeah, maybe to sum it up, of course, you have to take the data, look for the information, yeah, throw away all the stuff because you don't, as we said, not enough bandwidth. It's a whole problem. And if you just select the relevant information out of the data, of course you have to secure it, yeah, and to transport it and do all the encryption stuff. And on the other side you have the information, yeah. But that doesn't solve, yeah, the topic of the training data. So if we throw away all the data on the left and the right, we don't have the training data. And of course we don't, yeah, of course, let's talk about the German customers. We don't want to have our data somewhere else, yeah. So what do we get? It's a hen and egg topic, yeah. How do we get this without giving away the data? And maybe that will be one of the tasks to solve out in a single company. Maybe there is someone that has a software that sells the license to every single company sorting out their own data. Yeah, maybe that is one of a good business case for the future because nobody wants to give his data away. Yeah, maybe it's the other way around. So there is a company going to every one of us to sort their data. I don't know.
Olaf has actually inspired me for the following question. What all of you think about training on embedded devices? Do you do something like that, or do you prefer training in the cloud and then moving your models to the embedded devices? Let's start with you, Olaf.
Yeah. This is a pretty good point. I mentioned very briefly this topic, continuous learning. So meaning that you have a model, you're somehow satisfied with it, but then you have a change in your process and you want to incorporate this new knowledge inside your model. So and you probably don't want to retrain the entire model, just a little bit. So you want to continuously learn from your actual data. So I think for this kind of application, we need somehow training on the edge. So from my point of view, this would be the desirable solution to it, rather than to go back in the cloud and use this heavy, heavy CPU power. So I would be in favor of doing this on the edge.
You can still use heavy GPU power as well.
Say it again, please.
You can still use heavy GPU power.
Yeah, of course, yeah.
Yes, thank you.
Generally, I would say that's definitely desirable. I see that at customer sites, that they, exactly as you said, that they want to improve their production by retraining, and they don't want to do the whole do this all to the cloud, but do it locally would be perfect. It's definitely a need from a customer.
I personally think it's a big challenge, and it sounds like a very good direction, but it has lots of issues hidden inside it. So let's say we have two cameras on this audience, and they're all both starting from the same base model, but they're evolving over time, and we have no control of it. Otherwise, we could do it centralized. And now both of them are behaving differently. Technically speaking, they're all adjusted to the data that they see, but we as the users of this technology have expectation into what the product is doing. And the product that changes its behavior is something that is not necessarily easy to digest and easy to incorporate in a bigger system. So there's huge promise in this direction, but the management of this, I'm not talking about safety aspects or other issues which are of course much more complicated, but even if in non-critical tasks, the notion of a product that changes its behavior is on one hand very promising, but on the other hand also very challenging.
How about federated learning?
So about federated learning, the question is, do you have still a central entity which learns a single model that is then being distributed, or are you allowing each node to evolve on its own? And both of them are learning on the fly, but it's not the same behavior. And also the other question is, how do you validate what's evolved? Because we discussed this earlier. I mean, what do you want the product to do? Let's say I've only had people here moving in suits. And the next day we have here, I don't know if they do here conferences like this, but a sports conference. And now we have a different a camera that only identifies people in suits. Is it good? Is it bad?
Yeah.
So so maybe I can have a question.
Uh-huh.
You were talking about the camera, so are you saying like it could be that I have, for example, a degradation in the image over time? So I use a filter in the camera, for example, and it changes over time. So then I would really seriously get in trouble with the model I use. Is that what you were saying? That your accuracy and efficiency might totally
Actually,
change, right?
if you have something that physical, let's say the lens is deteriorating or whatever, or the filters or something,
Filter degradation or...
this is a very compelling use case because it's very local, it's specific to this camera, and we just want to correct it. Let's say that you have the means to evaluate the image quality, etc. But look at the data you're viewing. The world is changing, and it's different from different viewpoints. Is it desirable that you change your behavior according to what you see locally? It's kind of forgetting the global context for your very local context.
So I think to sum it up, it's a multi-level approach. So you have the smart devices that do their stuff. Then you have different nodes, like you said. The example is good with the cameras. Maybe I have one day with the business event and the sports event. They both can count people, but maybe it doesn't make sense to see if there are suits in the sports event. Yeah. So I have the different nodes, and at the end I maybe have the big cloud machine, yeah, that gets all the data. But so I have to separate these levels, looking for what do I need them for. They learn different, of course. Left side learns other than different, and of course I have to aggregate at some point these informations, but you should look at your system, which task is done at what time and how often, and how do I make sure that the whole system is improving in quality and not leading in different ways, and at the end you throw it away because it doesn't it detects only lightning because the people looked different the whole time, and I said, okay, the only stable reason is there are some lights and there's a black floor, and at the end the model says, yeah, black floor, lighting, it's the same location. So you have to look at different layers and levels and different tasks to do. Yeah.
And you know, the validation on data is so hard. Yesterday I flew into to Germany, so I did the experiment. I downloaded an application to my Android phone that does object identification, probably trained on a Coco data set. We're just seeing how it works. And amazingly, if you take it in an airplane, you will be surprised how many objects are identified as a suitcase. And you can see the bias in the data, because when it was pictured around airplanes, most things were suitcases, but these are not suitcases. These are just bags or cell phones or whatever.
Yeah.
And I guess no one tested this on a COCO data set in this case, but it's so hard to understand what happened to the model, at least the current state of the industry, that the challenge of understanding what actually happened is tremendous, I think.
My next question will be also related to your license plate example, where snow in Germany is considered a hazardous situation, I guess. So, and you know that embedded devices are often deployed in harsh environments. And what are your solutions for placing your embedded devices into such situations? Let's start with you now, Oliver.
Thank you. Yeah, we do some robust design for security applications and mobile applications. And of course, one thing is we have cameras, make sure that the camera does see anything. Yeah, so make sure that the system setup is working. Yeah, so clean the camera and the lenses and to get the data. Yeah.
How do you clean the camera? Do you send people to clean the camera?
No,
or
you
there are
have some windshields and wipers. Yeah, it's that basic
wipers.
difference. Yeah, and in industrial production, something else. Yeah, clean the view, so make sure that we see what's happening, or we will detect mud on the screen, so it doesn't make that good. And we have to make a robust setup, so make endurable electronics. Yeah, make it performable and make it robust against vibration and this stuff. Yeah, and then make sure that the view is good and we get the real data to see what's happening. Yeah. For example, before you stick out your head out of a vehicle, maybe it's good to see what's happening, who's out there, the good guys or the bad. So you look at the camera, and before you open up a hatch, you want to see what's happening there before you get in danger. And that's really important to have this direct view, and of course to check for the live application. Yeah, so it's a live indicator. Did the camera jam and we get the same picture over and over again? So is it live? Is it real? Is it actual picture out there? And it doesn't make it's no difference if it's a machine application or a person watching it. This make sure that the system is working correctly. Yeah. For example, live indicator in a camera stream. Yeah. Yeah. Is it still working? Yeah. And then you can rely on the information you get. So these are just some of the points that we look for, and that we build into the hardware and the software. Maybe even make redundant hardware and software loops to check some more sensors against each other to make sure that it's working.
Yeah, I mean, this is in the end, this is also one of the questions for me, which we focus mostly on the hardware or the system side, and for the cameras, we do mostly three things to make them more durable or protect them better. One is to have the temperature range, so a wide temperature range, go from below 0 to as high as possible, make it operational.
What is the smallest possible?
Well, for normal industrial cameras, it's between 55 or 65. But then for security application, it goes to 85 or even higher. So but between 55 and 65 is like a normal industrial application. So yeah, temperature range is one. And the other one is shock and vibration. So we test on shock and vibration over extended periods of time to make sure it doesn't fall apart or things don't scatter and break and things.
Just curious, how do you test for shock and vibration?
We do this in extra. There are labs to test this, and you mount it on a shaking plate, and you have several G's that you put on and you have sinusoidal vibration, or you have what's the other one? The more like if you just various waves of vibrations. So this shock and vibration testing, and then the third thing is really IP protection or ingress protection. So IP 65, 66, 67. The 6 is for like that it's particle proof, that there's no particles entering. The second is for water protection against different levels of moisture. So these three things are what we mostly do.
Very interesting.
And give it to customers and see what the response.
Well, but they usually want to know in advance. So, but of course,
sense.
And of course, you can, if you have big components and you go to the environmental lab, yeah, maybe after that there are tons of glue that you put on the components to make sure they stay at the same point. So at the end, glue it together or just screw it in a housing that makes it safe. That when you drop it, nothing happens.
Yeah.
To make sure it works. Yeah.
of course, you also want to guarantee a certain lifetime of
Yeah.
the components. That's another testing we do. The mean time between failure, MTBF testing,
Yeah.
or also we do sometimes highly accelerated live testings or HAL testing to just make sure that the components they last for a certain amount of time. It doesn't break after 2 or 3 years. But
What is the
usually
typical lifetime of the
lifespans
camera?
are usually longer, so 5 to 15 years, I would say. It's also really temperature dependent for cameras. So cameras, they degrade much faster in higher temperatures, or image sensors especially. So it really depends on the temperature also.
You mentioned the low temperature challenges, but for high temperature, the key aspect is to start with low power consumption, and then the HTOL, all the emission profile problems become easier. If you begin with that, depends of course on your hardware, your application requirements. If you start with a 7, 8 watt within a camera, it's a much harder problem than starting than 2 or 3 watts, especially when you talk about long lifetime of the device.
You're a software company. Do you also have any idea?
I was thinking, what shall I say to this question? Probably we also do shock and vibration tests in our office. I get a shock if I look at the source code of the developers and then start vibrating. So, but
I love it.
one comment maybe. There's a conference program just associated to the show here, and there's one track which only talks about the housing of embedded systems. So this is a real issue. And every electronics board needs to go through this vibration test. You have so many standards in different industry, up to military standards, which have very strong fulfillment, so to speak. So it's a real issue. And this is more the system thinking, so don't underestimate the system.
If I may ask, we talked about the hardware aspect of things. From software maintenance, you're maintaining systems for probably over 15 years now, deployed already. And most of the software world isn't built to maintain systems for so long. I'm not talking about the thermal degradation. How do you deal with that?
Yeah, I think lots have to do with the software design itself and to really look at also the old code, so to speak, again and again. So to really make an active life cycle management of the software. If you don't do this, then you run into a certain point where you have to start from the very beginning. So, you must do this because you have all these dependencies. You have these dependencies to the camera side, to the operating system, to all the drivers from whatever hardware guys. So you have to work on a very, interface level, a very high level interface level to make this happen.
We have to do exactly the same on the camera side. So also the camera software, that's the same. So if you build up technical depth over time, you just need to constantly also remove them and constantly, rework also the old stuff.
Yeah.
It's also very relevant for our cameras.
You wanted to add something?
Yeah, so it's the same. So if you visit our companies, you will go to the repair and test people, and then you will see some PCs with Windows 95 on it, or even older. Yeah, that's how we do it. We care for this old stuff. So if there is a customer sending us 3 units back, yeah, we try to make out of these 3 old two that are working, and then we take out the Windows 95 and do all the testing, and that's what we think about to care for. Yeah, so we care for all this old equipment and stuff, and keep it separate and running to be able to test all this, because it's not thinkable that when you have a big production machines and there is a tiny kind of electronics, camera or whatever, and then you say, okay, we can't repair it, let's throw away the whole machine. Yeah. So on the one side, you get a good money for it, but of course you have to care for it. And that's the how you position yourself in the market and what's your business case. And if you like these customers and you want to do the support for 5, 10, 15 or 20 years or not. Yeah. And for the German style industrial applications, most of the companies think in this way, they care for it. Yeah. But not every business model or product needs that approach. Yeah. But for industry or security applications, or I think medical too, they need this kind of thinking and approach. And so you have a very long-term perspective, and then you can care for the software. And sometimes you just have to freeze the status and say, okay, this one works, yeah, never change it, but this version works, yeah. And then you have the newest one. Of course, you can have different approaches on actual new software. You can develop it more, build in new features, yeah. So you have some time periods that stand for their own, and then you can care for this, and you can keep the systems running. Yeah.
Yeah, life cycle management is a really important question, and it's really also industry dependent. It depends on what industry. Like if you're in the medical industry, or I think also in aviation industry, you just have very long life cycles because you have so long it takes for the certification of the components or the system. It takes the customer 2 or 3 years to get the system certified. So then they also expect it to last for 10, 15 years. Well, we know kind of what kind of computer did I have 15 years ago. It's not so readily available anymore. So it's really an issue. Yeah.
We only have time for the very last question, and my last question will be, what advice would you give to developers and other stakeholders who are interested in working with embedded vision and AI at the edge? And what steps should they take to ensure the success of their projects? Let's start with you, Olaf.
Okay. I think if you want to get started with an embedded vision project, I would strive out embedded and vision and just say you start with a project. So, and the rules for starting with the projects are very simple. Take something which you understand, which is kind of easy to handle, where you can apply agile methods to move forward, and where you can see milestones in a short time frame. So the idea is to maximize the learning along this little project. And don't choose a mission-critical project on the first side. This is not a good idea.
I would say if you have already the project, you need to know the cost, like you touched onto it. You need to know the cost. You need to know kind of the go-to-market. When do you want to have this available? And then you also need to have an idea of how many pieces you want to produce. Because also the quantity of systems you need will govern quite a lot of design decisions, how you are going to go about. So I think those 3 questions, and then you already can get quite a good idea about the project. Also, if you talk to partners, kind of how to build this will give a good idea also to them.
The ecosystem is very important to have.
One of the mistakes we see people do is that they let this project to be led from, you bring an AI engineer, and then he or she has a very good idea, but it doesn't really meet a real project or a real product. And then and this is very different from typical software programs which were led by engineering, by product managers. And you need to figure out that contradiction very early on in the project and understand what you actually want to achieve and what you can actually do, and make it less of a research and more of a product orientation.
Perfect. It's a perfect answer for me. So I take all these steps, and my advice would be to grab some of your colleagues that have a different point of view on the topic. Yeah, one is looking for the business model, the next one is looking for the software, the hardware, and the training. And I think the team that consists of all these competencies, yeah, if you have the chance to get different kind of people thinking in different way and to sum up these approaches, then I think it's a good way to make a step-by-step access. Like we talked about, look about your ideas, do some experiments, try it. Yeah. Then you have scalable hardware, as we discussed before, and then get near your project step by step, because the learning phase during this time, yeah, could be months or 1 or 2 years, and all these topics that you learn and the steps that you make, I think that's the most important point. And I think most of the people don't expect where they may land after 1 or 2 years. I think it will be a great solution, but maybe not the straightforward, but somewhere in your target area. And I think that's be open and go the way and see if it's necessary for us. We have to learn and make this journey to this area of solutions. And wherever you end at the beginning, and at the end, it will be an interesting journey. And of course, it will be hard, and there will be a lot of tasks to solve. Yeah. I think that's best way. Yeah.
Brilliant. Thank you, everyone, for this nice discussion. And it was really amazing having you here and discussing the topics which we all care about so much. And thank you, everyone, for joining us today.
Thank you.
Thank you.